In the next topic, we'll study about the node voltage method. This is also known as node voltage method, or it is also known as nodal analysis. Okay, and it is also known as Kirchhoff current law. I told you about the Kirchhoff voltage law, remember? Now in detail we'll study about the Kirchhoff current law. Okay. What does Kirchhoff current law states that sum of incoming current must be equal to the sum of outgoing current. Okay, like suppose this is your room. So if there are four people entering in your room, then there will be only four people now which will leave your room, right or wrong? Hmm? So according to this, incoming number is 4, so outgoing number should also be 4. Suppose there is a wire, okay, and that wire is splitted into two parts. So this is how much? Let us consider 10 ampere. So suppose this wire is having 4 ampere. Can you tell me how much current can flow through this wire? 6 ampere, right? Because incoming is also 10 ampere and outgoing is also 4 plus 6, that is equal to 10 ampere. Got it? Hmm? Now we have to study in the form of numerical what is exactly Kirchhoff current law and how we can apply this method. Let us consider this diagram. In this, tell me how many meshes are there? 3 meshes. For 3 meshes, how many variable we need? 3 variable. And for 3 variable, how many equation we need? 3 equation, right? Okay. But in this we'll solve it by node voltage method or nodal analysis. For nodal analysis, we have to follow certain steps. Step number 1 is find out number of nodes. For this, you should know what is exactly the meaning of node. See, node is a point. Okay, node is a point where more than two branches are connected. Node is a point where more than two branches are connected. Okay, like suppose this is a point. Here, how many wires are connected? 3 wires, right? So this is a node. Now suppose, is this a node? Here how many wires are connected? 4 wires. So this is also a node. Okay. So in this diagram we have to see which one is the node. Now tell me, is this a node? There is only 2 wires connected. So is this a node? No, no. For node it should be more than 2, right? More than 2. Now tell me for this, is this a node? So we can mark it this node as A. Okay. Now tell me, is this a node? We'll mark it as B. Okay. Now this is also a node, not a node. Now these two are also node. We can mark it as C and we can mark it as D. Okay. Any doubt up to here? Now we'll do the reference, means we'll do the grounding for the reference node. Generally, we'll do grounding for which node? In which no element is connected. as you can see, between C and D there is no element connected, right? So we generally ground this node. So in ground, you know, the potential is 0, right? So here also a potential is 0 and here also potential is 0. Okay, got it? Yeah, generally we'll take it downward nodes, okay, for the reference node, as there is no element connected between these two nodes. So the potential across C point and D point would be same, right? Because there is no element, and that would be equal to 0 only. Understood? That is step number 1. Step number 2, we have to mark current direction in each branch. Remember, in KVL we mark it like a mesh, like in the room, but this time we'll mark it according to the branch. Like suppose in this branch I1 current is flowing, in this I2 is flowing, and in this I3 is flowing, in this I4 is flowing, and in this I5 is flowing. Okay, step number 2 completed. Now in step number 3, we have to apply KCL at node A. For node A, we have to apply KCL. I told you the statement of KCL, that is sum of incoming current must be equal to the sum of outgoing current, right? So just imagine that A point is your college, okay, and C and D point is your home, okay, just imagine. So now can you tell me which current is entering into the college and which current is leaving the college? Tell me which current is, like, just you can imagine also I1, I2 and I3 are your friends. So which of your friend is entering into a college? I1 is entering or leaving the college? Tell me. I3 is leaving the college. I2 is also leaving the college, but I1 is entering into the college, right? Hmm? So which of your friend is leaving the college? They'll add with each other. So incoming means entering. So that would be I1 is entering into the college and I2 and I3 are leaving in the college. So that will be added with each other. Is it this? Right? I1 is entering into the college. So that would be I1 must be equal to I2 plus I3. Clear? Any doubt up to here? Now I1, we have to see that your friend I1 is moving from where to where. Like you can see that I1 is moving from home to college or college to home. Just see the direction also. Now tell me, I1 is moving from home to college or college to home? Home to college. What is the potential at home? 0. And what is the potential at college? VA, right? So I1 we can write it down 0 minus VA, and if in between there is a battery, we have to take the second sign of the battery. That is, second sign of the battery is plus 12 divided by the resistance coming in the path. How much is the resistance? That is 4 ohm. Okay, I am repeating again. Here I am writing I1 would be equal to, I1 is moving from home to college, right? So that would be 0 minus VA. From where it is leaving, that would be positive, and where it is entering, that would be negative. So that would be 0 minus VA, and in we are having battery second sign is plus 12 divided by the resistance, that is 4. Okay, Now similarly, can you tell me the value for the I2? I2 is moving from college to home or home to college? Out of college to home. So it would be VA minus 0, right? So that would be I2 would be VA minus 0 divided by the resistance. What is the resistance in his path? 6 ohm, correct, divided by 6. Now similarly, tell me for I3. I3 is moving from VA to, you can imagine that B point is your gym, okay? Like now tell me I3 is moving from A to B, right? So that would be VA minus VB divided by the resistance. How much is the resistance in the path of I3? 7 divided by 7. Okay. So after solving it, can we get the single equation like that? After solving it, can we get the equation in the form of VA and VB, right? Okay. Now similarly, in step number 4, we have to apply KCL at node B. Okay. Now tell me how much is the incoming current at node B, means which current is entering into the gym. Tell me which current is entering into the gym. I3 is entering into the gym, right? That is I3 is moving from college to gym, means VA to VB, right? So we can write down I3 must be equal to I4 plus I5 because I4 and I5 leaving the gym, correct? Hmm. Okay, now tell me the value of I4. This one, yeah. See, in this we have applied Kirchhoff current law, that is sum of incoming current is equal to the sum of outgoing current. We are particular applying at node B, right? So this one is your node B, right? So node B, which current is entering? I3, and which current is leaving? I4 and I5, right? So can we write down I3 is equal to I4 plus I5? So I3 value we already know, that is VA minus VB divided by 7. Can we write down here? VA minus VB divided by 7 is equal to I4 value is VB. I4 is going from VB to 0, right? So it would be VB minus 0 divided by 8, correct? Then I5 is moving from VB to 0 again, okay? So we can write down VB minus 0. But for battery, we always have to take the second sign. What is the second sign from VB to 0? Negative or positive? Tell me, negative 10 or positive 10? No, second sign. Second sign is you are moving from B to 0. So what is the second sign coming in your path? That is minus, right? Minus 10 divided by the resistance, that is 9 ohm. Okay, got it? Now similarly we'll get the equation in the form of VA and VB. Now we are having two variable and two equation. We can easily solve it through the calculator.